Alright, so this is the 2018 FRQ number 4 for AP Computer Science A. Pause the video if you haven't read through the specs. Otherwise, we are going to get started. Alright, so for this problem, what we're doing is we're completing two static methods for array tester, and it looks like we're going to be working with one-dimensional arrays and two-dimensional arrays. So let's take a look at part A. Part A really seems like a very standard 2D array problem. Return an array containing the elements of column C of array 2D in the same order as they appeared in R2D. Right? So pretty standard. So for example, if we have this as our two-dimensional array, if we use get column and we specify column 1, what we're going to do is we're going to traverse those rows for column 1. And talked about the order. So the first number from top to bottom, they should be in that order respectively. Alright, so let's go ahead and get started with that problem. Let's see. Get column, so I'm gonna skip writing the header there, except for what I need. But maybe not confuse anybody. We know that we're gonna return a 1D array. It's called get column. It takes in a 2D array, and then it takes in the column. Alright, so for this method, the second parameter says go through and give me all the values for column C of the 2D array R2D. Very good. Again, pretty standard here. We know where you have to return a 1D array, so let's go ahead and declare and instantiate that resulting array. I'm just going to call it int result is equal to new int. So now the question is, how big of an array is it? Well, it's however many rows we have. So again, I'm going to drill down here, right? So if we have 3 rows, then the length is going to be the number of rows. So the column size is going to depend on the number of rows. For a 2D array, to get the number of rows, you do dot length on the name of the array. So that's going to be R2D dot length. Great. So now let's go ahead and iterate through the rows for that column. So really at this point in time, right, we have our empty array, and we just gotta fill it up with the values. Pretty standard. Alright, so we're gonna go for rows starting at 0 all the way to the last row, or 2D the length. Of course, it's gonna stop one before that. Then row plus plus. Alright, so for the current row, which happens to be its proper index within my 1D array, we are gonna grab an element from the 2D array, or 2D, at the given row and given column. Remember, you always want to think RC cola, race car, whatever makes you remember. RC cola, I'm not sponsored. Race car, blah blah blah. That's pretty much it. The only thing missing now, of course, is our return. If you have a method that claims it has a return type, it better return something. Return our 1D array result. Common mistake by students, for whatever reason, is referring, including square brackets here. You don't need to include the square bracket. Just return the name of that 1D array. Alright, so now let's move on to part B. Part B here is a little longer. So for part B, requires you to kind of take a look at what it means to be a Latin square. So here are two examples, a 3x3 here, and a 4x4. Alright, so they tell you a Latin square is where the first row has no duplicate values. So they should all be unique. 1, 2, 3, it looks like that first one, all unique. These ones, right, no duplicate values there, so that would pass the test. And then now the second requirement is going to be this one. All the values in the first row of the square appear in each row of the square. In other words, you want to check that these values all appear here and appear there. You want to check that these values appear there, there, and there. And indeed for these examples that is true. And then finally, not only that, but these values need to appear in the columns as well. So these ones, they appear in the columns, and they all do. Some examples of them, of not line squares. 1, 2, 1, 2, 1, 1. This one breaks that first rule. You cannot have a duplicate. You have two ones. The second example here is the fact that the elements in the third row do not match the elements in the first row, right? So all these are supposed to show up in every row. And this thing just died on me. No, what happened? Okay. Well, guess I have to exit that early. Alright, so we're gonna continue without the specs apparently. I'm gonna create a new sketch. Create. I'm just gonna grab the specs from somewhere else. Okay, let's see here. So 2018 number 4 part B. Number 4 part B is Latin. Okay, let's make sure this is still working. Golly. Alright, so for this one, discard current sketch, discard. So for this one, we know that we are implementing a Boolean function. Boolean is Latin, and then we're trying to figure out if the given parameter square is Latin. Okay, the first thing we want to do is we want to figure out if if the first row has unique elements. Good news is there's a variable called contains duplicates that we can use. And so what you want to do is kind of take a look at these guys, right? You want to identify what's available to you and use them to your advantage. Contains duplicates here will handle the fact that we need the first row to contain all unique elements. So we're just going to use that if contains duplicates contains duplicates, and we want to give it the first row, and we can just do that by specifying position 0 and disregarding the second set of square brackets. Contains square of 0. So this right here says grab the first row. Remember, in Java you want to think of two-dimensional array as a stack of 1D array. And so if we want to think of them as stacks of 1D array, then the first row is just a 1D array. And if that's true, we know right away that we return false. Okay, so the second thing we want to do is we want to take a look at the rest of the rows to make sure that that row contains everything from square 0. And so I'm just going to make my life easier and just create a temp variable here just so I can keep track of things. Int R0, I'll call it R0 is equal to square 0. So now we're going to go through the rest of the rows. So we're going to skip the first row, of course, for int row starting at 1 all the way to the last one, squared out length, and row plus 1, row is less than row plus plus. Alright, and then each time we want to call a method called, again, another helpful method called has all values. This method compares two 1D arrays to make sure that one array contains all the values of the other array. Perfect. Simplifies our job for us. So if has all values, if not has all values, compare row 0 with the current row we're interested in from square. If it's not the case that they both have the same values somewhere in whatever order, then we are going to return false. Great, so again, this set of code is going to check the rows. Finally, the last thing we want to do is check to see if the columns. For that one, we need to be able to grab columns. Remember, 2D arrays are stacks of 1D arrays, so syntactically there's not an easy way to get the columns. However, remember in part A, or the first part, we implemented a method that grabs a column, and that's where we're going to use it here. So let's write the for loop that's going to iterate through all the possible columns. For int call equals starting at 0, c is less than square at 0 dot length. Remember, this is the syntax for getting the number of columns for a 2D array. Column plus plus. Alright, so again, here this says generate all the possible column values. And so now we can just use the same method, but in this part over here, that's where it's going to differ, because we're going to send it a special. Why is this not changing? Okay, whatever. Right here, that's the only thing that's going to change. So if not has all values, compare it again to row 0. And we know we need to give it a second array. that second array is going to come from get column. Get column from my 2D array square, add column, column. If this is not true, if that returns false, then we return false. If we make it out of here, right? So this for loop checks the rows, this one checks the columns. If we make it without returning false, then that means we didn't break any of the rules. So we pass, and this entire 2D array called square is a Latin square. Alrighty. Let's